Alright, so time zones in MySQL. About Pythian is the company I work for. We're a recognized leader. We're a remote services DBA partner with MySQL. We're an Oracle Platinum partner. So I wanted to, this is about time zones in MySQL. Right now, the ISO SQL 2003 standard date time, there are some data types that are supported by MySQL and some that aren't. So in the SQL standard, date, time, and timestamp are supported by MySQL, but there are attributes that are not supported by MySQL, which are with time zone without time zone. This would be a very different talk if MySQL actually did support those, but it doesn't, so it is the talk that it is. MySQL additional data types, so in addition to, we just saw that it does have date, time, timestamp. So these are not in the standard, MySQL added them. Year 2, year 4, and date time. So basically, it's year X, but there's only 2 values. There's 2 and anything else. So if you specify year 1, MySQL actually uses year 4. If you specify year 5 or year 10, or you don't specify a quantifier at all, so you just say year, it's going to be year 4. So you basically have year 2 and everything else, which is year 4. So MySQL date time data types. So we talked about what they were, but now here's a little more information. Date is 3 bytes long, and you get from the year January 1st to the year 1000 to December 31st, 9999. Date time is 8 bytes, and you basically get the same date range, but from midnight on the 1st to 11:59 p.m. on the 31st of 9999. Timestamp itself is 4 bytes. That goes from January 1st of 1970, the epic, to the Y2K of January 18th, 2038 at 22:14 seconds, so mark the calendar now. The time itself is 3 bytes, and it goes from negative 838 hours, 59 minutes, and 59 seconds to 838 hours, 59 minutes, and 58 seconds. Why would you ever have time that has more than 24 hours? That's because it could be like elapsed time. Year 2 is 1 byte, and it's from 00 to 99 if you like Y2K issues. And then year 4 is 1 byte also. So it's the same 1 byte. It's just really what you're displaying, and it's 1901 to 2155. Here we go. Time zones in MySQL data types are not supported. If they were supported, we would have the with time zone with no time zone. However, timestamp, the field timestamp, is stored transparently in UTC. What does that mean? That means that if my server is in Pacific time, what actually is underlying is actually stored in Pacific time plus 8 hours right now. And it uses the time zone system variable to convert. So whatever the time zone is set to, it actually converts. You don't see that it's stored in UTC. When it's retrieved, it converts to the current time zone value in the server. So, because you don't see this can actually be a really weird thing. If you actually change the time zone of the server, so for example, I have this here. If it was May 8th of 2009 at 5 p.m., was stored when time zone was set to EST, Eastern Time, and then later the time zone is changed to Central Time, which is 1 hour behind. The value retrieved actually changes to 4 p.m. Now this is huge. Date time does not do this, timestamp does. This is not a problem unless you ever might change the timestamp, the time zone of your server, but if you do, it's a big deal. So when you're choosing between times, what kind of date time or timestamp should I have, you not only have the choice between 8 bytes and 4 bytes or the range, right? If you have something that needs prior to 1970, you're not going to use timestamp. You just can't. So if you have that, then you probably want to use date time. Or if you notice, actually, date time is an 8-byte number, and it is actually a number, in the line. Date itself is 3 bytes, and time itself is 3 bytes. So if you end up just having date and time be separate columns and end up putting them together whenever you do anything, that's actually 6 bytes. For the people that do actually, need to do that, I need a medium int because I don't need an int, and then, but 3 bytes is better. You can actually, do something with date and time. Now again, those do not change when your server changes its time zone. Timestamp does. So that is a big, big deal. If you're like, oh, all our servers are in Pacific, and what we really should do is just change them all to UTC, or change them all to GMT, and your system admins just go ahead and do it, you do still need to coordinate with them, because you have to look at all your timestamp values and say, is it okay that these are going to change? Because your reports might change. So I can actually show you that the timestamp is stored in UTC. I do like to have examples, so I will do that for you guys right now. Run a command. Can you guys see that pretty well? Here's my super secret root password on my laptop. It's just -root. So let's we're just going to create a timestamp table. So we use test and then database test, show databases. Create database test, use test, paste. So we have create table timestamp. We're just putting a timestamp and a date time and be able to compare. I just put engine equals my icing because, you know, it doesn't really matter. I can write engine equals date. So now I'm going to insert into time test. I'm just going to, you know, insert now and now. Paste. And then select star from time test. And we have 4:31:55 p.m. on the 14th is the same one for both. So now what I'll do is I'll change the time zone of this server. So what I'll do is I'll exit this. I'll shut down MySQL. So net stop MySQL. And if I do this again, I can't actually open link, right? So it's in fact stop. So now if I go to, actually I can just go here to properties. And, oh no, I go down here to date and time. Right, so now I'm going to set the time zone. So current time zone is the daylight time. I'll change it to Eastern time. Okay. And now you can see at the bottom here, you might not be able to see that, it says 7:32 p.m. But if I do this, I have to net start MySQL. Select now, I get that it's 19:32, it's 7 p.m. And now if I use test, select star from, what did I call it? Time test. Now the timestamp table, the timestamp field has changed to 7 p.m., but the date time field here is still 4:31 p.m. So if you mix time zones and date times, and then you go to change your data, that you're going to get weird issues. Which is interesting because, you know, before I started researching this, I had no idea that these were any different, and probably you guys did too. You're like, oh, just pick one based on how much space it uses during range. But you can also run into plenty of problems all on your own. So, the MySQL D time zone. So what's the server time zone? It's not always necessarily the time zone of the server itself. So MySQL D, you can actually have its own time zone if you really want. But what happens is when MySQL D starts, it finds the operating system time zone and sets the system time zone system variable. So if I go here and I say, show global variables like percent time zone percent, let's say. Right, we have system time zone, which is in Eastern Daylight Time, since I just changed that. And then we have time zone, which says system. So when MySQL D starts up, it changes it to Eastern Daylight Time. That's why when I change the time zone, I shut down MySQL, change the time zone, start it back up. If I change the time zone, and I can do that now, if I change the time zone without restarting MySQL, it's not actually going to, so let me set this to Mountain Time. Okay, so we have apply, okay. So now it's 5:34 p.m. If I do that, it still says Eastern Daylight Time because I have not. It's it's only when MySQL starts up that it looks at the system time zone and it puts it into this system time zone. So now this time zone, this variable time zone, says just use the system. But even if it said use a particular time zone, it would still set the system time zone. That's just something it does. It's just the variable that is there. By default, the time zone system variable is set to system, and the system time zone is used. So that's probably what you have on most of your servers. If the OS time zone changes, MySQL needs to be restarted for timestamp variables to change, and only timestamp data type fields change. And that bears repeating because, again, if you have date times, they don't change. A lot of us might just interchange the two of them. For example, timestamp also allows you to do current timestamp as, you know, on insert current timestamp, on update current timestamp. Only the timestamp field allows you to do that. So you can run into problems where you need to have timestamps in some things, and you need to have date times in other things. Getting the current date time. So current timestamp is the ISO SQL 2003 standard function for how to get the current date time that's supported by MySQL. Now is just an alias to current timestamp. So when we do select now, you don't have to worry. It is basically a standards compliant function. It's just that it's an alias to current timestamp, which is just much longer to type out. So now we actually have an interesting feature here, where if you now by default and current timestamp both will calculate what now is at the beginning of the run of the query, and we'll use that same value throughout the whole thing. For example, we're going to do select now, sleep 5 now. So what that should do is it will give us now, and then wait 5 seconds, and then give us the rest of, it'll get now again. So what it gave us is it gave us 2 of the same things, right? It gave us when it started. Right, so if we do actually this, we do select now, semicolon, right? So you can see, okay, 1937-08, is it going to give us, 09 or 08, or is it going to give us 5 seconds later? It actually gave us 08. So even though this second one ran 5 seconds later at 1937-13, it just gets the value of now, just calculated once for the query. Now, the reason that I bring this up is because current timestamp as well as now is replication safe. Okay, if your slave is in a different time zone or a different whatever, it's actually replication safe. The way MySQL does this is with this calculation that it does, it will put it in the binary log. It'll say set timestamp equal to a Unix timestamp number, which is that. And whenever you do now in that query, in the binary log, it will just input that set timestamp. Now, what if, so UTC timestamp is similar, is replication safe and based on current timestamp. It does the same thing, but basically all it does is it takes the offset. It says, okay, if I'm in Eastern time, I'm going to take the offset. That's -5. I think, yeah, -5 hours, and I'm just going to add that on. So UTC timestamp doesn't actually get the time in UTC. It just takes the current timestamp and adds what the offset should be. So because it's based on current timestamp, again, you get the same thing here. You get the same values here. It's just the UTC timestamp is going to be a little different. So if I, instead of select now, if I do select UTC timestamp, sleep 5, UTC timestamp, we get 1938 as the now, because we're still in Eastern time, and then it's plus 4 hours, I guess, because we're going to do that at the same time. It's plus 4 hours because it's 23:38:48. So UTC timestamp just takes, okay, it's Eastern time plus 4. Now sysdate, which people who use Oracle or whatever might actually know, it actually acts differently by default. So if we select sysdate, what we end up getting instead of UTC timestamp is we get the behavior that we might actually want in this case, which is that the second one is actually 5 seconds later than the first one. So here we start out 1939-27, so that should be what the first one is. So 1939-27, and then 1939-32, 5 seconds later, comes that second one. So if you were sitting a couple slides ago thinking, wow, that's not how I want now to work, well, you can actually use sysdate that way. However, sysdate is not replication safe because it doesn't use that current timestamp value, so it is not replication safe. So if your master is different from your slave in time zones, like if a master on the East Coast and a slave on the West Coast and they're both using their local time zones, then your times will actually be 3 hours different. So it's kind of good and it's kind of bad. There's if you want this feature, you can use sysdate, but if you use sysdate, then you end up getting this other kind of something that might be bug. So sysdate by default is not safe for replication, which is what I was just saying. It uses the system date and time, so the operating system date and time. It's calculated on an as-needed basis, so it was needed in the first part of the query, then it slept 5, and then it was needed again, so it was calculated again. And it will produce different values in a master and slave if the slave's time zone is different. You can make sysdate act like now if you really wanted to. So we had a client who didn't understand why their master and slave had everything was the same except completely different times. And what happened was they were using sysdate because they were, they'd come from the school of Oracle, and so they just wanted, now, and they used sysdate to get that. instead of changing all their code, what we did was we changed the sysdate is now a variable. You can set it equal to 1, or you can just set it. It's kind of like env file per table. That way, you just put it in the etc my.cnf. It's a static system variable, so you must restart the server for the state to take effect. It actually does not show up in show variables or show status, which is kind of annoying. And then what it does is it makes it act like current timestamp now, and default is off. So if you're not sure if you're using sysdate is now, unfortunately you can't say show variables like sysdate is now, but you can run this pretty easy test to say select sysdate, sleep 5, select sysdate, or sleep 1 even, or 2. And if it's different, then it's not set, and if it's the same, then it's set. So again, a little frustrating that you can't actually just say show it to me, but what can you do? The default is off, which means sysdate does not act like that. So, sources of information. So where are you getting now? A lot of times, let's say you have an orders database, right? And you say, okay, this person ordered, a product now. Well, do you get now from the database server, or do you get now from the web server application server? So a lot of times, developers will program it such that the now is calculated by the PHP code or the Java code or whatever. That can be problematic because if you have several application servers, several web servers, several nodes, if you're using Ruby on Rails and you're spinning up nodes, if each node has a different time, then you're going to get different absolute times, right? So if somebody buys a product at point A and somebody buys a product at point B, and they're 5 seconds apart, but the times on the servers themselves are off, it's going to look like it's different from 5 seconds apart in your database. Usually what I say is the best thing to do is just use the database, because usually you only have one of those. Hopefully you're only writing to one master. You can have master application, that's okay, but just only write to one at a time. And that way you'll be much more safe. Then you don't have to worry about making sure all of your web servers are in sync with NTP and all your database servers are all in sync with each other. What happens also if you have your web server in GMT and you have your database server in Eastern time, which is GMT -5, except for now when it's GMT -4. And an order comes in on December 31st, 2009 at 10 p.m. Eastern. If the web application server determines the time, then the order is going to be logged into January 2010. If the database server determines the time, the order will be logged into December 2009. And we're starting to do things like your gap analysis, your GAAP analysis, or when was the sale done? Was it done today or tomorrow? The extreme case is the end of the year, right? For taxes and whatnot. One thing that you can say is, well, as long as it's consistent, it doesn't matter, right? As long as 10 p.m. is 10 p.m. might be the next day, but as long as every day 10 p.m. is the next day, then that's fine. It might not matter, really, because it all kind of works out in the end. But it's something you have to think about when you're putting together these systems, especially if you have to be compliant with financial things like PCI compliant. So ways to convert in MySQL. So what if you want to convert times? If you want to convert times, you can use the function convert_tz. So convert_tz takes the time. It takes the convert from time to the convert to kind of offset. So basically, if you do convert_tz now, -5 to +0, what that's saying is take something that's now and convert it from, say, Eastern time to GMT, right? Because it was -5 and convert it to +0. So the offset is from UTC. So +0 means you're going to put it into UTC, and that's fine. If you're just adding 5 hours, you could say, well, why don't I just do +0 to +5? Well, you can do that. It's kind of a weak thing. We'll actually see a little bit later that you can actually put time zones in here, not just the offset. But you can't do that by default. You have to be using time zones within MySQL to do that. Daylight saving time can wreak havoc on your systems. You can end up having double the amount of orders or clicks or whatever. If you daylight saving time in the fall, it's spring ahead and fall back, right? So in daylight saving time in the fall, you fall back, which means that you have the hour 2 o'clock happens twice. So you end up having 13 hours in one day. If you really are looking at your sales numbers, you're going to say, wow, that's so weird. We've had like a 8.5% increase in sales. Why is that? So, well, you got an extra hour a day, or not 8.5, it's been 4.25% sales increase. You got an extra thing a day. Same thing in spring, when you spring ahead, you lose an hour. So all of a sudden your sales just go down. One day they go down. Now granted this is Sunday, so maybe you're not selling too much on a Sunday anyway, but whatever it is, clicks or whatever, end up going down. So if you have automated reporting looking at things, you're going to end up having a gap in the spring and double in the fall. And one of the biggest problems is that the day DST occurs is different for different countries. So you can't just say, well, on this day, everything goes back. Now that can wreak havoc because let's say you're on a social networking site and you want to know when a message was delivered, right? Everyone has their own local time zone. So when did I send a message to you? What's my time zone? What's your time zone? And then once you start getting daylight saving time, it can get a little crazy because again, the server itself is only one time zone, and it's probably not in my time zone. It's probably not in your time zone. It's probably some, it's probably in wherever the data center is. So there's a couple of different ways that you can take approaches to how do you store your data. So again, when we talked about a sale, or let's say an event occurring at 6 p.m. Pacific time, what does that mean? Does that mean if it happens at 6 p.m. Eastern time, is it considered the same time? Because basically wherever the user was, it was 6 p.m. their time. So for example, if you have a marketing application and you want to say, okay, when are people going on Facebook? Well, they're all going on at 6 p.m. Why? They come home after a hard day at work, the first thing they do, Facebook, okay? That's the kind of statistics that you want locally because it doesn't really, you don't really care that, that it's, 4 p.m. Or 2 p.m. Pacific, at 6 p.m. Eastern where you have, one marketing spike, right? You want to know, hey, people use this after work. Maybe I want to do some kind of promotion so they use it before work too. Maybe I want to make some kind of promotion so they use it during the lunch hour too. So, you might look at this and say, well, why would you ever do this? Well, that's why. This can actually skew reporting, especially when you're doing something like estimating peak times. If you're a system administrator and you want to know what the peak time is, it doesn't really help to say, well, 6 p.m. Eastern time you have a spike, and then 6 p.m. Pacific time you have a spike. What you care is what's the spike in terms of, when am I going to get paged, right? Wherever I am. If I'm in Eastern time, it doesn't matter if my server's in Pacific time. I want to know when am I going to get paged. If I go on the website and run a reporting query, when do I not want to do that because looking at the whole site. This is also problematic when a user's perspective changes relative to the time zone. So if I have something that happened at 6 p.m. my time, and then I move to a different location, let's say I'm traveling or whatever, do I still want to know that it happened at 6 p.m. my time yesterday? So for example, on your phone you get a call. And you get a call at 6 p.m. and then you travel and you go to, from the East Coast to the West Coast and it's -3 hours. Do you still want to know that yesterday you got a call at 6 p.m.? Or did you now yesterday get a call at 2 p.m.? It's probably a bad analogy, but there are some things where you can see where, it would be important to know, hey, what was that? A lot of times in like a Google Calendar or something, any kind of calendaring application, I had this problem actually with Google Calendar when I came out because I started putting it in all my sessions and I'm like, oh, I'm talking at 4:25 p.m. on Wednesday about time zones. And so I put it in, not thinking, and then when I came here, I'm like, oh, I'm going to get paged, about a reminder 10 minutes before. It's really going to be 3 hours and 10 minutes before. Now with Google Calendar specifically, you can set, the time zone or whatever of your view. So when you add in an entry in that view, then you can do that. But I didn't know that until after I encountered this problem where I realized, because people were setting up meetings and stuff, and they were setting up meetings in Pacific time, and I'm like, oh, I can't really look to see if I have a conflict, because I've done all the stuff at Eastern time by accident. Oh yeah, so I have my cell phone auto-adjusts my time based on time zone, but my computer doesn't. So that's kind of a problematic kind of a thing. Obviously, my cell phone company decides to, because it goes from the network, it decides to pick that up. My computer doesn't. I don't have it syncing anymore. So that's two different ways of looking at it. Is it better that my phone auto-adjusts and bad that my computer doesn't, or is it good that my computer doesn't? There's also, so if you end up using this it's all local approach, and by the way, you can use different approaches for different data and different tables. It's not like you have to pick one and use it for all your data, but you might have some marketing data that you want to do in one thing. So if you wanted to store two different events at the same absolute time in Eastern time and Central time, you can create a table, store time. So I'll actually do this because I find examples work really well. So what I'm going to do is I'm going to store times. I'm going to use a date time to do it. just so I don't have any, time zone things. And so we've got the stored time as a date time. We've got the OS, which is the offset, which is a tiny int. It's going to be assigned tiny int because I can positive or negative. And then I have the TZ, which is the time zone, which is a var6. And that's just it. There's nothing special about that. So what I'm going to do now is I'm going to insert some values, and I'm going to call them DT, because it's ST. Apparently I made a typo when I did it. Oh, it's probably DT date time is what I'm going to do here. So let me download the slides as we go. So let's draw a table that exists, store times. Try this again. So we created the table, we do an insert, select star from store times, underscore times. And you can see what we entered was we entered in, so it's the same absolute time, meaning that at the same point in time, somebody in Eastern time did something, and somebody in Central time did something. So you can see it's the same time here, and here's the offset, and here's the time zone. So we can convert back when we want to show it to the user, or when we want to show it to reporting or whatever. So the way to do that is you can use the time diff. So you can say time diff, the way that you get, well, what is, now that you're doing, you can say, you can use the time diff thing to get the offset, right? So what is the time, what is the offset going to be? It's going to be the time difference between now and the UTC timestamp. So basically what you're saying is you're storing it in UTC and then storing the offset. Got that? All right, everyone's nodding. Excellent. And then when you're done, when you're ready to get it, you can say select concat, the date time plus interval, OS hour, and the time zone store times. So paste that in. You'll see that we got it at, it was 2:52 Eastern time and 1:52 Central time. But in the database itself, right, it's all stored local to UTC. So the stored time is the same, but the display time is different. So that's the kind of, it's all local conversion. You're storing it locally, let's say the server's UTC, and you're converting when you come back. So you can also have it just all works out approach. So just store the times and dates any which way. Don't worry about the offsets. Don't worry about whatever. And if the date's not 100% accurate for what exact day or hour did it come in, it's still precise, it's still correct, and it's relatively accurate. So relative to each other, the data is accurate. Not relative to, my 6 p.m. and your 6 p.m., but relative to at what absolute time did the button get clicked, it was an hour apart. So 3 p.m. PST, I obviously apparently can't do math, and you've been calling me on this when I did it in Boston. 2 p.m. PST and 6 p.m. PST are EST are at the same time, apparently. No, it's 3 hours different? 3 hours different, okay. Well, so maybe I shouldn't have had that drink before my talk, huh? So 3 p.m. PST and 6 p.m. EST are the same time because it's the same absolute time, right? It's the same, right now, somewhere in the world, if somebody clicks, that's going to happen. For most companies, the relative time is important. It's often less important to know that 3 to 6 p.m. is peak time in each time zone, right? Your marketing people might want to know that, but your system administrator, your database administrator don't need to know that. It's actually more important to know that, hey, peak time on the website is 3 p.m. to 9 p.m. Eastern time. You don't care that it's 10,000 users from Eastern time and then 10,000 users from Pacific time. What you care is the site might die between 3 and 9. Any day or year straddling is consistent. So for example, if it's midnight Eastern time and at 10 p.m. Pacific time, an order is actually going to be considered the next day because 10 p.m. Pacific time is 1 a.m. Eastern time. So in your records, it'll say, oh, Joe Bob from California ordered a widget on April 13th, even though they ordered it April 12th. But it doesn't matter because every single day is going to have that break time. So it doesn't matter that your break-off period is not exactly midnight. It's just that the break-off point is the same every single day. So the only time you have to worry about it is if you decide to change when that break time is, because then you're going to have some time zones will have longer than a day, sometimes will have shorter than a day. So you can also have the store it all in GMT approach, which is you just convert it when you store it. It's easier to let a user change their display preference. because they could just say, well, I want to see it in this, and just change the offset. And problem is that application-aware reports may not match application-unaware reports. For example, your monitoring graphs were loaded on the server, that's application-unaware. But your monitoring graphs for, hey, what time is it where they are? You know, did they make a sale in the evening? That's an application-aware report, so it may not match it. So again, peak application traffic may be offset with peak network traffic, and if you end up doing your peak application traffic to say 6 p.m. is the most used hour in our application, then it's really 6 to 9 p.m. Eastern time that it's being used. And I'm only using this, but it obviously goes globally. It's just, it's hard enough to wrap your brain around it. You're talking about 3 hours of difference. It's, you know, when it's global, it's just 24 hours. So, you know, if your marketing folks say everyone uses it at 6 p.m., you know, then you have to really say, okay, well, let me see when the peak network traffic is, and like, why is it 3 hours? Is everyone using it from, you know, 6 p.m. to 9 p.m.? No, it's just that everyone uses it from 6 to 7 p.m. in their time. Daylight saving time can still be an issue. It's not so much an issue when you have it all just works out eventually, because again, you might have that, you know, double hour reporting, but you know, it all works out in the end because in the spring you get an hour less. So it's just a longer period of working out. Daylight saving time and the stored all in GMT can still be an issue, because GMT, by the way, is the winter time for Britain. BST is British summertime. It still has a problem. If you really want to do it, you want to do it in UTC, which doesn't actually affect with daylight saving time. Greenwich Mean Time actually is, you know, it's something that people think, oh, I'll just do it in GMT, but GMT is when you have that. There's actually British summertime in the summer for that. So again, when you fall back, there's twice the volume between 2 and 3 a.m. or whenever it changes, and there's not as much of an issue in the spring ahead because you just lose an hour. For example, you might have some problems where if you have a future date or a future time, your application might complain. So by the time you get to 2 a.m. the second time around, it'll be like, wait, I already have 2:59 a.m. in the database. Why am I 2 a.m. now? There's a future time, and that's not going to really work out really well for you. So store it all in UTC approach, if you really want the kind of let's just store it all and then do offsets, the UTC approach, you want to do UTC, not GMT. So in this way, you would convert all time values for storage and retrieval. It's harder to set up properly because for everybody, you have to have their time zone. If you don't have the time zone, how can you convert it? You know, you might set a default time zone in UTC, but if you don't know that I'm in Eastern time, how can you store anything that I do in time? But it might actually be the only way to have true unified reporting, because for the application-aware events, you just select it with the offset. For the application-unaware events, you just select it without the offset. Or you select everything with the exact same offset if you have a building in Britain. Most companies don't want or need to spend the time and effort necessary for this. You know, a lot of companies will just say, you know what, we know when the clocks change for us and for our major locales, and we'll just have to sit there and be like, oh, that's why the graphs look weird, because US and Canada just went summertime, and Australia just went summertime a couple weeks later. So what most companies do, by default, they do the it will all work out approach. They don't actually do it on purpose by default. They do it because they don't think about it. Just like most of us when we walked in had no idea that timestamp does what it does. You know, we didn't think about it until it became an issue, and then we're like, okay, now what do we do? If they need to reconsider, they usually end up doing the store it all in GMT approach, which, as you know, might not work because it's not really GMT. You want to store it in UTC. It's a subtle difference that people don't realize. Oh, GMT, unless you live in Britain, you might realize it. But GMT does get affected by daylight saving time. UTC does not. So, when can you have problems? How much time do I have? I feel like I'm going through these fast, but who knows? It's 5 o'clock. I start at 4:25, so I have till 5:15, 5:05, something like that. Oh, I have a schedule here, actually. 5:10, great. Okay, super. This is actually really perfect. When the server time zone, so you might have problems when the server time zone changes, as we said. If you stop MySQL, if you want to change the time zone, you have to stop MySQL, change the time zone, start MySQL. But when you do that, timestamps will change. So just be aware of that. If they're like, oh, we're just going to change everything to UTC, you know, and be great, and you're like, oh, well, just this will change. When the application servers and the web servers are different times from each other, with the database servers, we went over that, you know, especially if the code is coming through the web servers. You know, it's a weird conversation to have with, you know, the marketing folks and the product development folks to say, what do you mean by time? What does an order time mean? Is it when they click the order button in their location? So if they ordered it at 6 p.m. their time? Did they order it at 10 p.m. server time? What do we care about? And what do 2 events at the same time mean? So is it the same server time? So 6 p.m. Eastern time equals 5 p.m. Central time? Is it the same local time? So 6 p.m. Eastern time equals 6 p.m. Central time? Should it be the same time as headquarters? Should it be the same time as where reports are run from? So for example, if you put all your stuff in UTC and you're in the Pacific time zone and you're trying to say, okay, we had an outage, you know, yesterday at 3 p.m. and you go to look at your graphs and 3 p.m. is fine, but 11 p.m. is really crazy. Well, yeah, because 11 p.m. is 3 p.m. Is 3 p.m. Pacific time is 11 p.m. You know, UTC. It might just be easier to say, okay, you know what, the system admins live in Pacific time, so those reports are going to be in Pacific time, because that's important. But you know, financial reports, like how much money is in the bank, how many sales did we make, that might want to be run at the same time as headquarters, because headquarters cares like how much did we make yesterday, or what's yesterday. When they do the taxes, they'll probably end up doing it in that. So the MySQL D time zone, so I repeated that slide. Oh wow, yeah, no, we got a lot of new, actually, it's not really enough time. Oh well. When MySQL D starts, it finds its OS time zone. We did this before. So now let's talk about changing the default MySQL time zone. We can set the time zone option to MySQL D safe. Right now, MySQL D safe. Time zone equals TZ name, and I'll tell you where to get that later. Or set the TZ environment variable before starting MySQL. So, or you can set global time zone equals time zone, and the value, what values you can put in there are system dependent. You can change a session's MySQL time zone. So set session time zone equals -8. That's an offset. Names again, we'll talk about a little bit later. So you can select now UTC timestamp. So that's my cue to show you that. Paste. So if I set the session time zone to -8, which is Pacific time, and then I select now UTC timestamp, I actually get it's 4:03, but it's not really 4:03, it's 5:03, right? 5:03. But time zone -8, because right now we're in time zone -7, because of daylight saving time. And in UTC it's midnight. And then select star from time test, we can see again this changed. It should be the same, but because we changed the offset, it's different. We select global time zone and session time zone, it should be global dot time zone. We get system and then -8. So the session time zone has in fact been set. So it affects now, sysdate, and timestamp, but it does not affect UTC timestamp and date time. Now the reason it does not affect UTC timestamp is UTC timestamp is calculated based on the offset. So you might say, how come, I thought now timestamp and UTC timestamp are all kind of the same? No, not when you're calculating offsets. So using named time zones. So we were using offsets, but what if you want to use a named time zone like US Eastern or EST? So what you need to do then is you need to load the time zone information in the MySQL system database, which you may have seen. The MySQL system database will load this information, these tables. There's 2, 4, 5 tables. Time zone, which has the time zone ID. Use leap seconds, 0 or 1, yes or no. Time zone name has the time zone ID in the name, so the time zone ID is what pretty much joins a lot of the things. Time zone transition, we'll skip to that, which has TZID, transition time, and TTID. So when is the transition made? Is it made in November? Is it made in October? That's important. And then time zone leap second has the transition time and the correction. So anything happening at that transition time, that's what joins on. This is the only one that doesn't have the time zone ID as the joining key. And then time zone transition type has the time zone ID, the TTID, which is the transition time ID over here, the offset, whether or not it's daylight saving time, and the abbreviation. So if you want EST or US Eastern, it's actually here, I think. It might be in the time zone. That's what the next slide says. So if you want to load the time zone info, where do you get that information from? Some operating systems have time zone info built in the directory, like user share zone info. So Linux, Sun Solaris, FreeBSD, Mac OS X all have that. You use this command on the operating system command line. So MySQL tzinfo to SQL is a command on the OS command line, just like MySQL bin log or MySQL dump. You don't use it within MySQL, you use it outside of it. And then you take the user share zone info directory, and you can either cat it into a file, or you can pipe it directly into MySQL, into the MySQL user database. Or you can download the MySQL tables themselves from devmysql.com, downloads timezones.html. If you go to the manual page on time zones, it'll link to where it is, so you don't worry about copying it. You do want to reload periodically because in 2007, daylight saving time dates changed thanks to Bush and whoever was the Prime Minister of Canada at the time. They decided, let's change it. So we heard about that a lot, but you're not necessarily going to hear that Uganda changed their time zone or whatever. So maybe just once a year change your time zones and make sure they're accurate. So loading the time zone info. This is actually what happened when I ran it on a machine. I wouldn't be able to do this on Windows, so I can't test that out. I can't show you because it doesn't actually have, Windows doesn't have the OS time zone info, so I actually downloaded the tables here from that website, and I loaded them in. But if you did load the time zone info, you do something like this. Like I said, you can cat it into a file, and then you can, this actually tzinfo at SQL had these warnings, so Riyadh didn't have the same, it couldn't load a couple of things from Riyadh, so it skipped it, and then I imported it. When you test time zone info, so let's do this. Hopefully I've loaded the tables. You can use MySQL. I can show you these things. Paste. No, I don't have any time zones in here, but take my word for it because I have it here. If you select time zone ID from time zone name, where name equals US Eastern, you end up getting 561. So that's where you actually get the name. It is in time zone name. Select offset is DST abbreviation from time zone transition type, where time zone ID is 561. This is actually pretty interesting. So here's what you get. You get, here's EDT, so that's Eastern Daylight Time, EST, Eastern Standard Time. So is DST is 0 for Standard Time, it's 1 for Daylight Time. EWT and EPT, that's not a certain kind of a test or whatever. It's actually, I believe these are having something to do with wartime, actually. So if you see this is the offset, which is in, I think, minutes from GMT. Somebody can check my math, it might be seconds, but basically this is the difference, right? It's whether it's negative 5 hours or 4 hours. So I'll check my own math. Paste. So select 18, so it's negative 5 hours versus negative 4 hours. And if I actually had the tables loaded, I could say set session time zone equals US Central instead of -6. And then I'd be able to set the select now time diff now of that, and it would show me that if I did it properly. Parentheses, it shows me right now that the time diff between now and UTC timestamp is -8, because that's where that happens to be right now. But we did set the session offset to -8. Very quickly, convert TZ, you can use offsets or you can use name time zones. So we talked about now, -50, or you can use now US Eastern GMT instead of -50, or you can use session global variables, you can mix both. So you would say, okay, select now, and I want to convert TZ now, session.timezone at +0, or session.timezone and GMT. Most importantly, be careful, right? That's always the most important thing. Don't forget about existing data. Mass conversions can be done something like this. Update table set field equals field plus interval offset hour. So if you're going to do something like change the server time zone, you're like, okay, we need to increase the hour by 5 for each, each timestamp field, and we do something like that. Or you can use interval offset second, and the information for MySQL is the time zone transition type. So that was this, where we have this offset. You can say it's seconds. So you can say, okay, well, the offset is now going to be this. So you can subtract 14,400 seconds with using interval seconds instead of interval hour. This is only replicated properly in MySQL 5.0 plus. Hopefully nobody here is on 4.1. And if you want to learn more, you experiment and test, especially with master slave in different time zones. This is the time zone support manual page for MySQL. And there's just one more thing. I wrote the MySQL Administrator Bible. It makes a great doorstop if you need to raise your monitor up, and I hear it actually has some good information in it. I wrote it, and I can tell you there's a lot that I learned writing it. So even if you're an experienced DBA, you'll learn something, but it's kind of set for people who are like new or intermediate. Come on up, leave your business card. We're going to do the drawing right after everyone puts their business card up. And if you have any questions, comments, or feedback, here's my information. If you're in the market for looking for people to come and see if you're ready for production of your database systems, or you need kind of an audit, that's something that we do as well. So that's all I have. And hopefully I'm not too much over my time. But thank you guys.